Hello friends, this is a example of objects submerged in a fluid and whether or not they are going to sink or float. Get ready for it. So, updated toolbar. Distracted me for a second. Amazing what gets into our minds. Anyway, let's say we have two objects that are the same size. They're 1 liter balls. It's like this big, like a big grapefruit, I think is a liter. We usually don't see liters in spherical form. Makes me wonder the exact radius of a liter. Side question, what's the radius of a liter ball? 0.001 cubic meters equals 4/3 pi r cubed. What is r? Go. Cool. Then find something that's a liter ball. Let's say I have one that's made of brass. That would be about 5 kilograms per liter. Again, I don't know if that's exact our density of brass, but we estimated our little friend in class to be that big. And let's say one is 200 grams of a mystery substance. Right? And to convert to kilograms. 0.2 kg, that would be. What is their density? And what happens? What happens? What is the acceleration? To know that, we need to know the net force. To know that, we need to know FB and mg. And we need to draw a force diagram. For those of you who aren't clear, I call it force diagrams. I never understood the term free body diagram. That always confused me. Because it's not free. It's under the direction and influence of forces. So why don't we call it what it is? What are you doing? You're drawing an object and you're drawing the forces on it. Force diagram. But for those of you who were taught that that's called a free body diagram for reasons I still don't understand, it's a free body diagram. Same thing. Just my preference. So what do we do? This is what you do. Do this every time. I mean, this is F equals ma, right? So you're drawing an object, it's got a mass, right? What's pointing down? Gravity. What's pointing up? Buoyancy force. That's what we learned yesterday. Buoyancy force always points up, gravity always points down. So the F net is, well, we need to figure out which is bigger. You can always, option 1, always choose positive to be up. And then F net is always FB minus mg, because mg is then negative. But as you remember, really important that there is no, gravity isn't negative by definition. Gravity is 9.8 as we measure, and it's mg by definition from Newton's version of it. But it's not negative. There is no negative. In space, there's no negative force diagram. This isn't defined as negative. We have to choose positive and negative. You have to choose your own coordinate system, choose your own reference frame. I'm hoping that was established in your Physics 1 teachings. Or you choose, this is my favorite, choose the larger one to be positive. So I'm gonna stick with this one. Although this one's kind of fun. Like I said, it's my favorite, but this one's more consistent. I know I just said gravity isn't negative, but let's choose it to be negative just for ease in this circumstance. For instance, if I were to just drop something and I just said, okay, mg down, drop, I would make that positive. And then its velocity is positive, right? What's its velocity? Well, its velocity is some positive number when it hits the ground. Everything's positive. That's what I would do. Just an example of hold on. I'm still getting used to this new. All right. It erased some other things. This is crazy. Look, it erased that. Little bugs in Zoom. All right, ready? Let's do it. So F net equals up minus down. Great. You guys already know how to draw forces and do F net equals MA, and then you set that equal to MA. Cool. So if M is 5 kilograms and what was it? Volume is 1 liter. 1 liter is 0.001 cubic meters, or in other words, 10 to the negative 3 cubic meters. Please know that. That's a big deal. 3 stars means know it. I don't know what 3 stars means, know it. That's my know this, remember this. Yep, cubic meters. All right. So density will be 5,000 kilograms per cubic meter. How did I get that? 5 divided by 1,000 gives me 5,000. That's the density of the object, which might come up later. But for now, we're just going to do F net. Well, it was also a question. I asked it, right? It's 5 times as dense as water. F net equals FB minus mg, and that equals ma. I know that FB is rho fluid Vg. So I plug that in there. That's a big deal. So I'm going to rewrite it as rho fluid Vg minus 5 kilograms times G equals 5 kilograms times A. Now, if I wanted to do this in general, I just realized I could do it like this. Rho fluid times G minus rho object times V times G equals rho object times V times A. That's kind of cool, right? Because that's M. M is rho object times V, and I know the density of the object, and I know its volume, so I could do it that way. So that's really smart. So where are we at? We're at, here we go, rho fluid times volume times G minus mg equals ma. Rho fluid is 1,000. Now I'm just going to plug in volume is 0.001. G is 9.8 minus 5 times 9.8 equals 5 times A. So this is FB. In fact, we should get FB separately. FB is 1,000 times 1,000, but there's 1 that is 9.8 newtons. This is 5 times 9.8, or mg is 49 newtons, which wins? Well, gravity wins. So in this case, we have buoyancy forces 9.8 newtons up, 49 newtons down. The net force is, you could say 9.8 minus 49, just to be positive minus negative. Or you could say, sorry, I'm just doing some math. Or you can just say bigger minus smaller, and then the acceleration is down. Either way, we get that it's negative 39.2 newtons, but the negative has a meaning. This is the whole point. Here's what I mean. It doesn't matter, and it does. It doesn't matter whether you call this negative or not. This means down. What does the negative mean? The negative means down. It's a vector. So F net is down. Therefore, acceleration is down. So what does it mean? It sinks. Do you see that's the whole point? Is that it sinks to the bottom, it goes down. So we set this equal to ma, then we get that acceleration is 39.2 over 5, which is 7.84 meters per second. You might notice that that's smaller than gravity. That's the point. Buoyancy is pointing up against gravity. So you can think about that for a second. If something's always submerged in a fluid, oh, and by the way, this was in water. Submerged in water. then there's always going to be that force upward. In fact, there's a force upward on you right now, a buoyancy force on you that takes away from your weight. So you actually weigh a little bit less being submerged in the atmosphere than you would have otherwise. So what changes if we switch the mass to 200 grams, which is 0.2 kilograms? Well, the volume stayed the same. So the buoyancy force stays the same. Remember, what's the buoyancy force dependent on? Same volume, same buoyancy force. It depends on volume. So rho fluid Vg is still going to equal 9.8 newtons. Same volume, same everything. But now the mass has changed. So now we have 0.2 times 9.8, right? But mg, this is my star, is less. Right? mg equals 0.2 times 9.8 is 1.96 newtons. So now this wins, which means the buoyancy force 9.8 is now bigger than the 1.96 down. So the net force is up, so the acceleration is up. So we get the net force here being (9.8 minus 1.96) is 7.84 newtons. That's an interesting coincidence. That was the acceleration before, but that's not the same thing at all, right? This is force. Set that equal to ma. We get acceleration is F net over m, 7.84 newtons over 0.2 kilograms, careful, divided by 0.2, and we get 39.2, whoa, positive 39.2 meters per second upward. Now that's interesting that, look, the force and the acceleration change, that is nuts. That's because this is a fifth. This is 5 and this is a fifth of a kilogram. I think that's the reason why. That's crazy, right? Whoa, trip out on that for a second. Either way, we get an enormous, that is bigger than gravity upward. So that's going to shoot up out of the water. Have you ever played with one of those like pool noodles or like a floaty thing or held a basketball underwater? We're going to do that next week, by the way. It just flies up because all of that, some of those pressure forces, remember that's what buoyancy force is, some of the pressure forces is so strong compared to its weight. It has no weight compared to this, that just flies upward out of the water. Either way, that's how you set it up each time. That's what we're doing. That's the answer to the question. And that's it. See you guys in class.